Hello everyone, welcome to my free online tutorial for the new SAT Math section. Now the problem that you see on your screen right now comes from the official SAT study guide just released by College Board. This study guide is meant to help you prepare for the new SAT Math uh, exam version coming up in March of 2016. So this problem is problem number 1 from the first exam in the calculator section. Okay. Now, this problem tests your understanding of graphical analysis. So it gives you a graph in 2 dimensions. The first dimension is time. The second dimension is the target heart rate, beats per minute. Okay. So it tests your understanding of slope and what it means, what the positive slope means, what the negative slope means, and what the zero slope means as well. Okay, a steady horizontal line here that you see. So John runs at different speeds as part of his training program. The graph shows his target heart rate at different times during his workout. On which interval is the target heart rate strictly increasing, then strictly decreasing? So let's understand what this question asks you. So it asks you to find the interval in which the target heart rate after strictly increasing will strictly decrease. So in other words, when you're thinking of strictly increasing the heart rate, right, for a certain time frame. So let's take this time frame from 0 to the 10th minute, right, for the first 10 minutes of the recording device, right? So we have an increasing slope, right? The slope is positive, it's increasing. So in other words, the number of beats per minute after the 10th minute, right, of the recording in the recording data will be higher, right? It will be a greater number of beats per minute for the heart rather than at the very beginning. So at the very beginning we were looking at something like 65, right? Something like that, 65 beats per minute, just when we started recording the heartbeat. And then after the 10th minute, you see the heartbeat was around, well, it was actually on the 80, so it was 80 beats per minute on the 10th minute. Now notice that for the next 20 minutes, from the 10th to the 30th minute, the heart rate is the same, right? The average heart rate is steady. It's not decreasing or increasing in beats per minute, right? It's steady 80 beats per minute for the next 20 minutes. So this would not be a valid answer to what they're asking you. They're saying on which interval is the target heart rate strictly increasing, then strictly decreasing. So in other words, you need to find a time frame somewhere here in which the heart rate increases, showing a positive slope, right? The line goes up somehow, and then it goes down immediately after that. It's not going to have a steady beats per minute, the steady heart rate for a certain time frame. It's not going to have that. So this would not be valid. All right. So let's see what happens. So after that we see a steady decrease, but then before that we had the same constant heartbeat, which is not what we're looking for. So this period is not valid. From the 0th to 40th minute is not a period of recording that we need to be looking at. So let's take a look at the next period. So from the 40th minute to the 50th minute, we see an increase in the number of beats per minute, the heart rate. And that's from about, let's say 90, something like that. So increases from 90 to 120 beats per minute. So by the 50th minute, you see an increase. From the 40th to 50th minute, there's an increase in the heart rate. The number of beats per minute is greater. It's 120. And then what do you see? You see an immediate decrease in the number of beats per minute for the heart. So there's no period after that in which the heart rate is steady. It goes down, right? The number of beats per minute decreases from the 50th to 60th minute. So this looks like a valid choice. Let's just take a look at the other time frames, the remaining time frames, to just make sure that this would be the best one. So far this looks like a really good answer, right? So let's take a look at the choices that we have. So choice A says between 0 and 30 minutes. That's not good. We already warded that off, right? We didn't like that. Now choice B says between 40 to 60 minutes. That looks like it's good because we just took a look at it. There's no time frame in which the heart rate was steady, right? It was increasing and then strictly decreasing, right? Let's take a look at other times. Choice C says between 50 and 65 minutes. Right, so 50 is here and 65. 65 is there. Well, this would be wrong because from 50 to 60 about, it goes down. So we don't see the increase. So we should be looking at the increase first and then decrease. So 50 would be, choice C would be wrong for that matter. Now choice D says between 70 and 90 minutes. Let's take a look at 70. At 70 first of all we have a steady heartbeat, heart rate, right? And then we see a jump, right? And that cannot happen because this is a discontinuity, right? First of all, there's no increase here because after the 70th minute we still have a steady rate, and then there's a discontinuity and we're given an immediate jump, right? So this would not be valid. And besides, when we get to the 90th minute, we don't see any decrease whatsoever in this period from the 70th to 90th minute, right? So this would be actually incorrect as well. So the only choice that seems to work is choice C, because that shows choice B. Choice B, between 40 and 60. So from 40th minute it goes up, right? The heart rate increases, and then from the 50th minute to 60th minute, right, for choice B, it decreases. Okay, so this would be the best choice, and indeed this is the correct choice, choice B.